This is the second session in the year 11 to 12 bridging course, and it's on algebra. In this presentation, we're going to concentrate on these topics. The first 4 topics are in GCSE, so we'll go quickly through these, and then we'll concentrate on the remaining 3. Surds, simplify numerical expressions involving surds. So simplification of expressions involving surds, like a bracket squared minus another bracket squared. So if we square the first bracket, we square the first term, we double the middle, so twice root 6, and we square the end term, so 2. Square the other bracket, remember to keep the minus outside, so 3, double the middle, so minus 2 root 6, plus then 2 for minus root 2 all squared. Take away the minus, collect terms, and we see the 3 minus 3 disappears, the 2 minus 2 disappears, and we're left with 2 minus 2 root 6s. So we've got 4 root 6 for that expression. So simplified. If we have a fraction, we need to rationalize the denominator. So we need to get rid of the root 3 on the denominator. So what we do is multiply top and bottom of the fraction by an expression to get rid of the surd and the bottom. Now what we do is put a plus and minus, the same element inside the bracket, so that we got a difference of 2 squares. So at the bottom, on the top, we've got 2 plus root 3. And at the bottom, we've got 4. And the plus and minus 2 root 3 will cancel. And then we have plus 3. Root 3 times root 3 is 3. So that gives us 2 plus root 3 over 1, which is 2 plus root 3. So 2 different situations we're using surds. Now there's some questions here for you to do. These are all stuff you've done in GCSE just to get you back into the swing. The answers are going to follow. So some of them are fractions, some of them needs you to expand, take out a square from there, try and do them without the calculator, because they could be on paper which will not allow you to use a calculator. So try and do them without the calculator. Right, if you want to stop the video to do them now, do so, because the answers are following, or you can do them at the end and cover the question, cover the answers. Answers are coming now. Second topic, we've got indices. Indices with negative and fractional values. So if we've got 8 to the power 2/3, that means I want the cube root of 8 and square the answer. And it's usual to do the root first and then square the answer. So a cube root of 8 is 2. 2 squared is 4. A power minus means I put it on the bottom. So I've got 1 over the 4th root of 16, which is 1 over 2. So half. Anything to the power 0 is 1. Then I've got 16 to the 3/4. So 4th root of 16 to the power 3. 4th root of 16 is 2. 2 cubed is 8. So that's the things you do with indices. Sometimes you get letters. So if you're multiplying letters, the same letter, the same base number, and different powers, you add the power. So you've got 2/3 plus a half plus 5/6, and all to the power half. So add those as fractions, put them all over 6, and you get 12 over 6 to the power half. So you multiply the 2 powers then, and you get y to the 1. Now if you have a plus in a fraction here, you can't do anything to the indices. You have to look to see what's common, what can you take out of the expression on the top here. So I can see that I've got x to the half common to the top. So if I take x to the half outside a bracket, I have 5 left on that side plus 6. And if I've taken a half out, this is 3 over 2. Take out the power half, and I got x to the 1. So I got 5 plus 6x inside, and 7x to the power half. The x to the power half will cancel, and I'm left with 5 plus 6x over 7. Questions for you to do. Answers are going to be following. So either stop the video and have a shot at them, or do them at the end. The answers are following now. So there's the first one with numbers, and the second one with letters. So the third topic we're going to have a look at are factorizing quadratic expressions. So have a look at the first one here. You need to see what's common between the, being as we've got two terms, is there something common? Well, we can see that 3 is common. So if I take 3 out, I've got x squared and then minus 16 left. Can I factorize that? Well, yes, I can. It's a difference of 2 squares. So it's going to be a plus and a minus 4 in the bracket. So there's that one fully factorized. This one, where you've got 3m squared, so that means 3m times an m at the beginning and a 3 times a 1 at the end. Now you want a minus 10 in the center, so common sense will say I need the 3 on the end, the 2 3's on the end, so 3 3's are minus 9m, minus a 1m gives me a minus 10m. So manipulating the brackets, seeing what you need, manipulating the brackets to get the middle term coming out. Now this one, the last term is a 2 and a 1, and it's going to be a minus and a plus. Don't know which is which. Then you've got for 12, you can have either 12 and 1, 2 and 6, or 3 and 4 to make 12. So you need to manipulate around and see what you get. Now if we do the 3 and the 4, so we've got the outside giving us plus 80 and the inside giving us minus 3d, giving us a plus 5d in the middle. So you know you've got the 2 and a 1 on the end. Then fiddle about with the beginning so that 12 to see what gives you the plus 5d in the middle. Like I said, these could be on the paper where you have no calculator. Formation and manipulation of quadratic equations. So if we have a rectangle who's got a longer side of 2x plus 3 meters and a shorter side of x plus 1 meters, and its area is 66 meters squared. So write down a quadratic equation which is satisfied by x and arrange it in the form ax squared plus bx plus c is equal to 0, where a, b and c are integers. Then solve this equation to find the dimensions of the rectangle. So draw a picture first to see what we've got. We've got 2x plus 3 on the long side, x plus 1 on the short side. You know its area is 66. So I multiply these. I got 2 brackets to multiply. So 2x squared plus 2x plus 3x plus the 3 is equal to 66. Collect terms in order. So we got 2x squared plus 5x. Bring the 66 over. We go minus 63. Now does this factorize? So the 2 and the 1 at the beginning. 63 could be 3 and 21, or it could be 7 and 9. You've got to play about with the last figure here to get which factors will make sure you've got a plus 5 in the middle. So if you've got minus 9x for the outside, plus 14x, giving us plus 5x for the middle term. So manipulating factors to get what you need. We need to solve this now. And we get x is minus 7 and x is minus 9 over 2 or plus 9 over 2. So we can't have x being a minus number or we have a negative distance there. So we cross out the x is minus 7 as being impossible, and then we take that x is 9 over 2. So x is 9 over 2, then we'd have the length being twice 9 over 2 plus 3 being 12, and then 9 over 2 plus 1 is 5.5 for the width. One for you to do, factorize and then solve the equation. The answer is following, so either stop the video and have a shot before I put the answer in, or do it at the end. And those are the answers. Right, simplifying algebraic expressions involving fractions, equations and expressions involving fractions. So if we have this equation here, we've got 3 plus a fraction is equal to another fraction. Give your solution corrected 2 decimal places. Now you can either multiply through by 3x and by 2x minus 3, or we're going to rationalize, combine the left hand side into one fraction. So I'm going to put the 3 with the 3x over 3x, and I've got the x minus 6 on the left hand side. So now multiply both sides by 3x and by 2 bracket x minus 3, and we get, so this term becomes 9x plus 1x, which is 10x minus 6. Multiply that with 2 bracket x minus 3, and then multiply the right hand side with the 3x with the bracket 3x plus 1. Multiply out on the left hand side, so we've got 10x squared minus 6x minus 30x, giving us minus 36x plus 18, 9x squared plus 3x on the right. Multiplying the left hand side out and collecting terms, we've got 20x squared minus 9x squared is 11x squared, minus 72x minus 3x is minus 75x, and plus 36x is equal to 0. Now it's not going to factorize because the question says correct to 2 decimal places. So either use your calculator, or if calculator not allowed, use the formula, and we get answers of x is 0.52 or x is 6.30. Completing the square. Now this is a new topic. Use the method of completing the square to solve x squared plus 5x minus 3 is equal to 0, and express your solutions in surd form. So what we do for completing the square, we want a square number is equal to an ordinary number. A square bracket equal to an ordinary number. So if you consider the first 2 terms here, you take the first 2 terms, so I've got x, take x squared, so take x from the x squared, half the coefficient of x, so 5 over 2 for the x. If I square this bracket, I've got x squared plus twice the middle, so that's 5x, plus 25 over 4, which I do not want. So I take away the square of the last term, and I've got the minus 3. So I'm manipulating the expression, the quadratic expression, to make a square number, a square bracket, and a number. So if I tidy up the, so I've got 25 over 4 minus 3, minus 25 over 4 minus 3, so that gives me minus 37 over 4. That becomes 12 over 4. So I've got minus 37 over 4. So I want now that quadratic is equal to 0. So instead of the quadratic, I've got this expression. It's completed square expression. So I've got x plus 5 over 2 squared minus 37 over 4 is equal to 0. I can take that over. So I take the square root, plus or minus, and then take the 5 over 2 over. So I've got that expression as the solution in surd form. Another question. Complete the square to find the minimum value of x squared minus 16x plus 61. Now, if you think of an x squared graph, it points down. It's like a U, which points down, and so we can find the minimum value. But we're going to use completing the square to find this. So you take the first two terms, x from the first term, half the coefficient of x, so I got minus 8. I want to square that bracket, so I'll have 8 squared, twice the middle, which would be minus 16x, plus the n term squared. So I don't want the n term squared, so I don't want 64, and I want to add the 61 that was there anyway. So I've got x minus 8 all squared minus 64 plus 61 gives me minus 3. So that means that at the point x is equal to 8, think about the bracket equal to 0, at the point x is equal to 8, y is the point minus 3. So the value of the graph, the minimum value of the graph, the pointed end, the stationary point, is at y is equal to minus 3 when x is equal to 8. So the minimum value of that is minus 3 when x is equal to 8. So using completed square, I can do that. Questions for you to have a shot at. So there's 5 questions here. I'd like you to use either complete the square to find the least value. There's a few of those. Or just putting them into completed square, least value, then solve the equation with letters in, and then least value here. Answers the following. So if you want to stop the video and do them now, or you want to do them at the end, it's up to you. Answers are coming now. The remainder theorem, or factor theorem, this is a new topic as well. And the situation is, if f of x is divided by the term x minus a, the remainder is f of a. And if x minus a is a factor, if it's a factor, there is no remainder when it's divided, then f of a is equal to 0. Then either do long division to find the other factors or manipulate the terms to get the other factors. So the first one, find the remainder when 2x cubed plus x minus 5 is divided by 2x minus 1. We do not do a division here. What you do is imagine the 2x minus 1 equal to 0. So if I get x is equal to half, instead of dividing with 2x minus 1, I put x is equal to half, and I work out what the function is with x is equal to half. So I've got 2 times a half cubed plus a half minus 5. Half cubed is 1/8. So 2/8 plus a half minus 5 gives us minus 4 1/4. That would be the remainder if I did a long division with 2x minus 1. Show that x minus 1 is a factor. And if it's a factor, then my remainder would be 0. So I imagine that to be equal to 0. So I want to put x is equal to 1 into the function. So 1 cubed minus 7 times 1 plus 6 is equal to 0. So the x minus 1 is a factor. Question 3. When x cubed plus 2xy plus a is divided by x minus 2, the remainder is minus 3. Find a. So if I'm dividing by x minus 2, I put x is equal to 2 into the function. So I got 8 plus 2 times 4, which is 8, plus a. I want that answer to be minus 3. So 8 and 8 is 16. Take it over is minus 16 minus 3. So a is minus 19. Question 4, show that x minus 1 is a factor of this expression and hence factorize the expression. So if I know that x minus 1 is a factor, I put 1 as x, I put 1 instead of x, put it equal to 0 because it is a factor, therefore no remainder. So I've got 2 times 1 cubed minus 1 squared minus 2 times 1 plus 1 becomes 0, therefore x minus 1 is a factor. Now if it is a factor, I can either do a long division or I'm going to manipulate the expression in this second bracket. Now if x minus 1 is a factor, I know the second bracket is going to have 2x squared at the beginning because I've got 2x cubed at the end. I know I've got a plus 1 at the end, so I need a minus 1 at the end of this one. Then I don't know what the term in x is going to be. So I need to multiply this expression out. And I get 2x, multiply everything with x first. So 2x cubed plus ax squared minus x. Then multiply with minus 1, so minus 2x squared minus ax and a plus 1. So the two end terms are what I wanted. The x squared term is a minus 2 and I need a minus 1. And the x term is minus 1 minus a and I need a minus 2 for that one. Therefore, a must be equal to 1 in both situations to get the cubic expression to come out. Therefore, my factors, first of all, I've got x minus 1. Then my second factor was 2x squared plus x minus 1. Does that factorize? Yes, it does, to 2x minus 1 and x plus 1. So it's fully factorized. That expression is fully factorized. Questions for you to have a shot at, and answers are following. So either do them now, stop the video, do them now, or do them at the end. So I've got find the remainder, factorize, if you know that x minus 2 is a factor, and hence factorize, and two other ones which are nearly the same. So the answers are following now. Some more, giving you more chance to manipulate your algebra, and those are the answers to those. So the last topic now, simultaneous equations with one linear and one quadratic equation. Use the algebraic method to solve the following simultaneous equation. So we've got an x squared plus an xy equals 18, and then a linear equation which is x minus y is equal to 5. So from the linear equation, take one of the letters, and this time we can see that x is equal to 5 plus y. So substitute the 5 plus y into equation 1, and we got 5 plus y all squared plus 5 plus y times y is equal to 18. Multiply the brackets out, so we've got 25 twice the middle, so 10y plus y squared for the square bracket, and then 5 times y plus y squared is equal to 18. Collect terms, so we've got 2y squared and plus 15y, bring the 18 over, so we've got plus 7 is equal to 0. Does it factorize? Yes, it does. So 2 and 1 at the beginning, 7 and 1, where can I put the 7 and 1 to make 15y in the center? So if I put the 7 in the end, I've got 2 7s of 14y plus 1y is 15y. So y is equal to minus a half, or y is equal to minus 7. Giving us, go back to equation above where x equals, and we've got x is 4.5 or x is minus 2. Question 2. Calculate the coordinates of the two intersections of the curve y equals x squared and the line y is equal to 3x plus 4. These are simultaneous equations, but they both y equal. So I can put them equal to each other. So x squared is equal to 3x plus 4. Collect terms, put them in order. So x squared minus 3x minus 4 is equal to 0. That factorizes to x minus 4 and x plus 1, giving me minus 3x in the middle. Therefore, x is equal to 4 or x is equal to minus 1. X is equal to 4. Y is equal to 16 or y is equal to 1. So the coordinates of the intersections are minus 1, 1 or 4, 16. And if we look at the graph, there's the y equals x squared is in red, and the line y is equal to 3x plus 4 crosses at the point minus 1, 1 and 4, 16. Questions for you to have a shot at. Either do them now, so stop the video because the answers are following, or you can do them at the end. So simultaneous equations, one quadratic or one with multiples of x's and y's, and one linear. Take the linear and substitute into the other one. And then question 2, find the coordinates where the two, the curve and the line intersect. And then a question where you have to set it up and then work out the answers. So answers are following now. And that's the end of the session on algebra.